Welcome back, guys. So previously we were talking about the nature of bonding and obviously the properties of simple covalent molecules. We saw that they have low melting and boiling points because they have weak intermolecular forces. Remember, we were seeing that these are simple molecules, small molecules, and one molecule is attracted to another molecule with very few, very weak natured weak intermolecular forces, or also known as IMFs, and these forces could be overcome really easily. They don't require as much heat. Molecules get some heat, they vibrate, they move away from each other, and that is why they had less melting and boiling point. We know that they were normally gaseous or liquid at room temperature because they had lesser melting and boiling points, obviously lesser than 25 degrees Celsius. And then we saw the fact that they do not have any mobile electrons, as all the valence electrons were already occupied in covalent bonding. So when electrons were shared, there's no point in expecting out of them that they'd conduct electricity. So they could not conduct electricity. In today's video, we're going to jump off to the concept of metallic bonding. So we're talking about metallic bonding. Metallic bonding happens only in two cases. Case number one is a pure metal, A metal which has no other word attached to it would be the indication. For example, if I say just sodium, if I say just iron, if I say just copper, not oxide, no carbonate, nothing, that's gonna be pure metal. And the other case would be alloy. We're gonna have a whole video about alloys, but we know that alloys are mixtures of metals with other elements. So there are metals, right? And they're mixtured. So they're not chemically combined with other elements. They are mixtures. Alloys are not compounds. Let's have the structure of a metallic compound. For example, I'm talking about copper. So let's say copper is generally pink in color. So I'll be taking this color over here. I have few of the atoms of copper over here. We had an introduction to this metallic bonding in one of the previous videos, but we know that let's label it that these were copper atoms. But what they do is they all lose their valence electrons and they become positively charged ions. So they all lose their valence electrons and they become positively charged ions. Each copper atom loses 2 electrons. It totally depends on their valency, by the way, but I am making them lose their 2 electrons. So these are copper plus 2 ions. This whole structure over here is a metallic lattice. This whole structure over here is a metallic lattice of positive ions. I should write over here, metallic lattice means a lattice of positively charged ions. Positively charged ions. Obviously metal ions. Obviously when the metal has lost its electron, the electrons are hovering around over here. They are right over here, and each metal atom has lost its 2 electrons, which are not going away. They're right over here. Non-metal atoms are not here. No one's gaining the electrons. The metal electrons are right here, and the metal electrons over here, it's really important for us to know that metal electrons over here, they keep on moving around. So these electrons are not fixed. These electrons are delocalized electrons. You can call them mobile sea of electron. You can call them the delocalized sea of electron. So I'm going to stop their moving, obviously, and this is the mobile sea of electron over here. This is the mobile sea of electron. You can also call it the delocalized electrons. That is the same thing. Delocalized electron. Now let's talk about their properties. Their first property would be that obviously they have electrostatic attractions between them, because when we look at the metallic lattice, it has electrons which are negatively charged and the lattice of positive ions. So they have electrostatic attraction between them. So we should not forget over here that they have electrostatic attractions, which are really strong, guys. So we should know the fact that their first property, we're writing their properties and their reasons, right? Properties, reasons. Their first property would be that they have very high melting and boiling point. What could be the reason for that? The reason would be that they have strong electrostatic forces of attraction between what? Between the mobile sea of electron and the lattice of positive ions. So strong electrostatic attractions between the mobile sea of electrons and the lattice of positive ions. Everyone, let's not forget the fact that lattice is a regular arrangement of particles. It could be ionic lattice, it could be metallic lattice. Right now we are talking obviously about the metallic lattice. Lattice of positive ions. They need a very large amount of heat to overcome the forces. So very high heat is required to overcome this force. So the metal lattice is in no mood to move away from each other. So the lattice is very strong. The metal ions are not going to move away from each other. So lattice requires high heat to overcome the forces. Forces are always overcome. They can never be broken. You don't break forces, you overcome forces. Keywords are going to be strong electrostatic attraction between mobile sea of electron and obviously the lattice of positive ions. You need high heat energy to overcome the forces. Guys, their next property is going to be, obviously we just saw the fact that the mobile sea of electron can move, right? So the mobile sea of electron can move and conduct electricity. So if you want them to conduct electricity, it's very much possible for them. So they conduct electricity. In which state of matter? In solid, liquid, both. So solids and liquids both. How do they do it? Obviously by the movement of mobile sea of electron. So mobile sea of electron moves when a voltage is applied. When a voltage is applied. Remember the fact that the positive ions do not move. The positive ions or the lattice does not move. The positive ions do not move, right? So let's underline the fact. Mobile sea of electrons moves when a voltage is applied. Positive ions do not move. Cool. Next thing would be that these compounds obviously have a high electrostatic attraction, high melting and boiling point. That's why they are solids at room temperature. With very few exemptions like mercury and sometimes cesium, they are generally solids at room temperature. We know the answer because the melting and boiling point is very high, and that is why they are gonna be solids at room temperature. One thing that is unique to metal is that their malleability or ductility. They are malleable and ductile. Now what's the meaning of those words? The word malleable means can form spreaded sheets. It can form spreaded sheets. Ductile means can be rolled out into wires. So the whole idea of making sheets or obviously wires is that they are flexible. Why are they flexible? How are they so strong yet flexible? Because the metallic lattice has layers, and these layers can obviously slide over each other without breaking apart, without the attractions being overcome. So for example, let's have layer number 1, and let's have layer number 2. Obviously, both are copper layers, so they are positively charged over here. These are also copper atoms, just differently colored, and their mobile CF electron is also here. This is my mobile CF electron, which is very randomly arranged over here, right? Cool. These layers can slide over each other. Without moving away from each other. So that is why metallic lattices are malleable, ductile, and flexible. So they have layers in metallic lattice which are not very loose, they are very strongly held. They have layers in metallic lattice held together by the electrostatic forces that can slide over each other. So overall, they become really flexible. You talk about layers being held together by electrostatic forces, the word of layer should be there, the word of slide over should be there. So in this video, we have talked about the structure and the nature of bonding in the electrostatic overall idea of metallic bonding, and we saw how metallic compounds or metallic substances can have their properties represented or explained using the metallic lattice idea. So in the next video, we're going to be jumping to a very new concept of macromolecules. So stay tuned, guys.